here we go. We are ready for the meat of this class. And for a lot of people, the unfortunate meat of this class is that there is a lot of overlap between math and chemistry. We need to know how to do a lot of good math in order to be able to do the chemistry we're talking about. Because a lot of what we talk about in chemistry is, yes, conceptual. We talk about atoms and molecules and how they interact with each other and what they do. But when we want to actually do something with this, when we want to use these concepts and these numbers about atoms and molecules to talk about concentrations of solutions or acidity of solutions or calculate how heavy something is, we need to be able to introduce math into there. So this is a comic from XKCD and talks a little bit about the different fields and how pure they are. It's a funny little one. Chemistry is kind of right in the middle there, that biology is just applied chemistry, but the physicist says, oh, you know, that's just applied physics. And the mathematician way over there on the side says, hey, this is a very pure field. When you just do math, it's kind of abstract. So the nice thing about doing math and chemistry is that we're a little bit more concrete. We're applying it to something specific. But there's a bunch of algebra that we're going to need to do in order to do the chemistry that we want to do. What I'm going to do is I'm going to review a little bit of that algebra. I'm not trying to teach it to you. I'm just reminding you what you need to know. And if there's things that are a little bit, I don't quite remember that, then you can go ahead and find some other videos, Khan Academy or other things like that, to help you along, reminding you of some of these things that we need to know for the class. So some things I expect you to know is order of operations. You might have learned PEMDAS at some point. Calculate things in parentheses. Then you do powers and exponents. Multiplication and division just from left to right. There's no priority in multiplication and division. Then you do addition and subtraction also from left to right. And so what we're going to do is a few problems here, and we're going to see what happens when we do these problems. Let me blow this up. If we do 3 times 5 plus 4 minus 2, we've got to do PEMDAS, which says we're going to do that 3 times 5 first, and that's going to be 15 plus 4 minus 2. And then we do the addition just left to right. So we've got 15 plus 4 is 19, minus 2 is 17. We can take the exact same numbers, but if we change how we group them together, then we get something different. Here we've got the parentheses around the 5 plus 4. So even though it's an addition, the parentheses make it take precedence. And so we have to do that one first. 5 plus 4 is 9. So we actually have 3 times 9 minus 2. 3 times 9 is 27, minus 2 is 25. And then we can add some exponents there if we want, and we can also make sure to do exponents early on in our priorities. 3 squared is 9. So we've got 9 times 5 plus 4 minus 2 squared is 4. These guys cancel out. So we just get 9 times 5 is 45. So being able to do those kind of number work is really important in this class. We do a lot of addition, subtraction, multiplication, and division. So remembering how we do those and what order we do those is a good thing. Other algebra skills I expect you to have coming into this class is understanding what a power is. When I say 10 to the 5th, hopefully you remember that what that means is that's 10 times 10 times 10 times 10 times 10. 5 times you multiply by 10, and that's what 10 to the 5th means. We're also going to be using negative exponents. And all that negative means is it doesn't mean there's any negative numbers here, really. It just means that instead of 10 times 10 times 10, we're having 1 over 10. So 10 to the minus 5th is 1 over 10 times 1 over 10, 5 times. And so this one is about 100,000. And this one is 1/100,000th. A very, very small number, 0.00001 if you did that as a decimal. We also use our exponents for units in chemistry quite a lot. And so instead of saying just 10 to the 5th, we also say things like meters, m cubed. So we've got m to the 3rd, and that just means the same thing. 10 to the 5th means multiply 10 5 times. M cubed means multiply m, which is meters in this case, 5 times. So meters cubed is m times m times m. We then try to make it even a little more complicated for you and say, hey, let's use it as fractional units, grams per cubic centimeter, grams over centimeters cubed. We could write that out as 2 separate units, grams times 1 over centimeters cubed right there. But that centimeters cubed is centimeters times centimeters times centimeters. So we end up with 1 over centimeters 3 times. And the reason that's important is if we wanted to convert this number, we can't just convert centimeters once, we'd have to convert it 3 times. And we'll see things like that as we move on in the class. I also expect you to understand kind of multiplication and division of powers, that when you have 2 exponents and you multiply them, you add their exponents. So 10 to the third times 10 to the second is 10 to the 3 plus 2, which is 10 to the 5th. And that's a large number, right? When we see these positive exponents, we know we have large numbers. 10 to the 4th times 10 to the minus 3rd is going to be 10 to the 4 plus minus 3. And that's going to be 10 to the 1st, which is just 10. And then dividing these powers, I expect you to be able to do that as well. And again, I'm expecting you to know how to do that. Mostly in this class, your calculator is going to do that work, but it's also good to be able to double check what your calculator puts out to make sure that it's what you think it should be putting out. All right, when you divide them, you subtract them. So we've got 10 to the 4th minus 3, and that's going to be actually 10 to the 7th. So a big number. So be aware that when you divide these exponents, sometimes you get these weird results. Like, oh, isn't 10 to the 4th times 10 divided by 10 to the 3rd something kind of small? No, because when you divide by a negative exponent, you get these bigger numbers. But again, we'll be doing most of this in our calculators, but it's good to be aware of what to expect from your calculator. So without calculators, take a moment, see if you can solve this problem. 10 to the 8th divided by 10 to the minus 4th. And a lot of time in the class, I'll be saying these things. I'll say, hey, try to solve this problem. Sometimes we'll be doing it on a site where it actually pauses for you and tries to make you solve the problem. And sometimes I'll just say, hey, pause the video right here and you try it. And it's a good idea. It's a good idea to interact with this material, not just stare at the screen and go, because how much are you going to remember after 15 minutes of that? So 10 to the 8th divided by 10 to the minus 4th, pause the video, try it yourself. What you should have gotten is 10 to the 8th minus 4, which is 10 to the 12th. So you should have gotten B. We're going to have a lot of numbers in this class. Lots and lots of numbers. We're multiplying numbers of fractions and things on top, things on bottom. We have to make sure that we're using our calculator properly in order to do these kind of problems. So I've got this kind of big problem in front. Yeah, I've got this big problem in front, and what I want to do is say, how are we going to put this problem into our calculator in a way that's really, really easy? And the general rule I use on top is that when something's on top, it's multiply. And when something is on the bottom, it's a denominator. You're going to divide. And it's an easy way to put things in our calculator where we don't have to put a bunch of things in, write down a temporary number, put something else in, write down another temporary number, put things all the way back in. Even though there's a fairly complicated looking problem that's in front of us, the 35.35 times all these things, I can put it in kind of my calculator all at once, and it actually reduces your chances of error. So this one, since it's not part of a fraction, that isn't on top, right? It's kind of implicitly divided by 1, so 35.35 is going to be on top. The 0.029 is on top, the 1374 is on top, so all three of these are going to get multiplied by each other. And even though there's these other things occurring in there, I'm going to do all my multiplications first. And so what I'm going to type in my calculator is 35.35 times 0.029 times 1374. And I'm not going to hit enter here and write down a number. I'm just going to keep going and then divide by everything that's on the bottom. And so everything that's on the bottom looks like this, which is 437 and 0.0038. And so everything on the bottom gets a divide. And you're going to see what I mean by that in just a moment. Divide by 437, divide by 0.0038. And it looks kind of like I'm taking and I'm dividing by 437 divided by 0.0038. It kind of looks like that. But your calculator doesn't put those parentheses there unless you tell it to. It just goes left to right. It multiplies those 30 things, then it divides that total by 437, then it divides that total by 0.0038, and it gets you the answer that you want. So I'm going to actually show you my calculator so you can see me putting this in. I apologize, there's a little bit of delay on my calculator from when I reach over and type things in to when it actually shows on the screen, but hopefully we'll get it down there. So I'm going to take my calculator. and I'm going to type my numerator, my 35.35, and multiply by 0.029. Now you'll notice I didn't put my leading zero there. I didn't put 0.029. You can, but on your calculator it's not required. When you're writing things out, I highly encourage you to do that, and we'll see why in a little while. 1374. We do that, and then we divide by 437, and we divide by 0.0038. Okay, so now I can't see the left-hand side, but as I was typing it in, I was verifying that I typed my numbers in correctly. I hit equals down there, and I get 848.221185, etc., etc. We'll learn in a little while that we're going to round that out, but for now, let's just kind of put 848 as our answer. I encourage you to get your calculator out and make sure that you're able to get that result as well when you do the problem. Let's do our next one. Everything on top gets a multiply, everything on the bottom gets a divide, even though there's a bunch of multiplies down there. Okay. I'll show you two ways of doing this one, because some people are uncomfortable with this everything on the bottom gets a divide, and I understand that. But let's do it first the way I said. Everything on top gets a multiply. 19.3 times 4.29. Everything on the bottom gets a divide. 23 divide by 4.2 divide by 9. That's what I'm going to go ahead and type into my calculator, and it's going to look something like this. Let's clear that off. And then I've got my 8.4, my 19.3, my 4.29, and then divide by my 23, divide by my 4.2, and divide by my 9. Okay, because you can see I've got 3 division operators there, no parentheses or anything like that. And I'll show you in a moment how you can do it using parentheses, but for now let's do it without. And then you press enter, and you get your number, which is 0.79997, and a bunch more digits. We're going to say just 0.800. We'll go ahead and round that, and we'll see more rules about rounding later on in the class. But that's how we're going to put stuff into our calculator. Anything on the top gets a multiply, anything on the bottom gets a divide. For those of you who are uncomfortable with that rule, we can use parentheses. You don't generally need to if you're just multiplying on top, so I'm going to put the top stuff in the same way. But on the bottom, if you like to, you can use a set of parentheses and then times. And so I'm going to put a parentheses there, and then 23 point, oops, no, 23 point, it was 23 times 4.2 times 9. And you can put that into your calculator too, and you should get the exact same answer. It's a good thing to try. I don't mind either way that you do it. How I do it is I do it the first way. Everything on the top gets a multiply, everything on the bottom gets a divide. The only time I end up using parentheses is when I've got addition and subtraction as part of my numerator or denominator, and we'll see an example of that in a moment. Okay. Units. We're going to put units on just about every number we talk about this semester, and we'll talk about units in the next section of the video, or there's the next video. However, one thing to keep in mind is that units don't go into your calculator. Your calculator doesn't care. Your calculator doesn't know what a unit is. Only numbers go into your calculator. So I've got on top 0.35 times 4.32 divided by 0.795, and that's 1.9. And that's entirely equivalent to the problem on the bottom in terms of what your calculator does, which is 0.35 milliliters of arsenic times 4.32 grams of arsenic for 0.795 milliliters of arsenic gives us 1.9 grams of arsenic. All those units there, the milliliters, the grams, the arsenic, your calculator doesn't care about those. And so one of the things you want to practice in this class is not getting overwhelmed by all the units that we have. That remember, units and numbers are actually kind of two separate problems. And we can work out the numbers on our calculator, and we can work out the units in a way that I'll show you later on in one of these videos for this part of our class. So just be aware, those two are the same. You'd enter in 0.35 times 4.32, divide by 0.795 for either one of those problems. All right. How about if we have addition and subtraction in our numerator and denominator? One way that I see people do it a lot is they calculate those numerators and denominators, they write them down, then they plug those things back into their calculator, and there's nothing wrong with that as long as you're writing down a lot of digits and making sure you're not just rounding things too soon. But you can actually enter in those into your calculator all at once as well. Everything on top gets a multiply, everything on bottom gets a divide, but when there's addition and subtraction, those additions and subtractions have to go inside parentheses. So what I would type into my calculator, and I'll show you right after I do it, is 42.4 times parentheses 17.438 minus 16.838 divide by parentheses 24.5 plus 18.3 plus 4.2 close parentheses. That's what I'm going to go ahead and type into my calculator next. So we'll give that a clear, and we start typing our 42.4 times, and then we have an open parentheses right there, 17.438. And it's always good to look at the screen, verify that you entered in that number right, that your decimal point is in the right spot, because it's really easy to accidentally enter in something wrong. And for a calculator like this, it does disappear off the screen after a little while. 16.838. Really important that I put in that close parentheses there. If I don't, my calculation is going to be wrong. Then I'm going to put that divide, and I'm going to put those parentheses there, and put the 24.5 plus 18.3 plus 4.2, and then I'm going to put my close parentheses there. When I type that in, I get 0.5413. I'm just going to round, and that would be our answer in that one. So numerator gets a multiply, denominator gets a divide, put parentheses around any addition and subtraction. And if you do that, you'll be doing really well with your calculator in this class. What do you type in your calculator for these ones? So I'm not going to test you on this, but take a moment. I would suggest pausing the video, typing those into your calculator, and seeing what you get. Hopefully you did that. When you see a 1 in a calculation, you don't have to put that in. Because remember, anytime you multiply 1 or divide by 1, nothing happens. You can put it in. It's not a problem to put it in. But it saves you a little bit of time if you don't have to. Because we actually end up, in some of our conversions for this class, we end up with a lot of 1s. And so if you can not put those in by practice, you'll save yourself a little bit of time. So everything on top gets a multiply. 43 times 753. And everything on the bottom gets a divide. 428 divide by 4. That's what you'd put into your calculator. If you put that into your calculator correctly, what you should get is about 18.912967. Lots and lots of digits. We'll talk more about it later. Let's go ahead and just round that to 18.9 for now. How about this one? What are we going to enter into our calculator? Hopefully you had a chance to pause the video, try it out. 12.8 plus parentheses 14.32 plus 19.2 divide by 12.3 divide by 54. I didn't need to use parentheses on the bottom there because that was a multiplication, and multiplication and division are the same order of operations. So I can just use the divide. I could have also, on just that end part, done divide by 12.3 times 54 if I put it in parentheses. Either way is fine. Okay. And if you plug that into your calculator, you get number 0.645974 with much things. Let's go ahead and round that to 0.646 for now. Good idea to practice with your calculator. Good idea to make sure you know how to use your calculator properly for this class. A lot of times the errors that we make aren't actually errors in the thought process, they're calculator errors. I try to spot them when I can, but I can't always. So this one is one for you to go ahead and try. Pause the video, try it out, see what you get. Okay. Hopefully you plugged in your calculator something like 7 times 8 times 43, and then you divided by 19, and you divided by 9. If you do that, you get about 14.08 which we're going to round 14. Hopefully that's working well for you. Another thing I expect you to be able to do for this class is some basic algebra. So rearranging some equations in order to solve for variables. So we're going to do just a few examples here, and then you'll get a chance to try some examples on your own. A equals b plus c, if we're going to solve for b, what we want to do first is we want to subtract c from both sides. Remember, if you do the same thing to both sides, then you are fine. So I get a minus c is equal to b plus c minus c, plus c and minus c cancel out, and so I get a minus c equals b. Most of the time people will write the thing they're solving for on the left, and so I can flip that and say b equals a minus c. There's no problem flipping inequality, right? You can write 3 equals 2 plus 1, or you can write 2 plus 1 equals 3. Not a problem. Our next one, we're going to take multiplication and division. We're going to try to solve this one for c. Now, I'm going to show you a wrong way first. What I see students do all the time is they say, oh, my c is on the right, so I just need to get rid of the b. So I'm going to divide both sides by b. My b's cancel, and I get that c is a over b. I see that all the time. But you didn't actually solve for c, right? C is still in the denominator. We don't want c in the denominator. You solved for 1 over c, which is not what you want. So the first thing I always recommend when you've got a multiplication division problem, if you see what you're solving for is in the denominator, get it out of there. How do we get it out of the denominator? We multiply both sides of the equation by c. That cancels our c over here. So now we have c times a equals b. We want to get c all by itself, so we're going to go ahead and divide by a in our next step. Those a's cancel, and I get c equals b over a. Those are two things, addition, subtraction, simple manipulation of multiplication, division, or most of what we're going to be doing. Occasionally we have both addition and subtraction, multiplication, division. We need to solve for it. So let's go ahead and solve this one for d. The first thing we need to do is actually get rid of the e, because if we just divide both sides by c, then we've got still e over c on the right, and it gets a little harder. So I'm going to go ahead and subtract off e from both sides. And so I get ab minus e. These guys cancel. So I just get cd on the right. Now I can divide by c in order to get d all by itself. So my c's cancel over here, and I get that ab minus e over c is equal to d. And I can flip that around, as I said, and write it this way, ab minus e over c. So that's how we do some simple manipulation of algebraic equations. Like I said, we're going to do a lot of that with addition, subtraction, multiplication, division, and occasionally with mixed. So certainly make sure you can do the addition, subtraction, multiplication, division manipulations really well. Your turn. We've got v equals m over d. I want you to solve this one for d. Pause, try it out, then we'll come back. All right. I'm going to write it out with things on top. It's usually easier to see when it's on top rather than that slash notation. If I'm solving for d, I can't just divide by m, and I certainly can't multiply by m. That's another thing I see students do all the time, is they multiply by m, and they say, oh, look, my m's cancel. But if I've got m in the numerator here and m in the numerator here, what I end up with is m squared. Right? If I had 3 and 3, I wouldn't end up canceling them. I'd have 3 times 3, which is 9. So we can't just multiply both sides by m. What we need to do is get our d out of the denominator. So let's go ahead and do that. How do we do that? By multiplying both sides by d, because then we've got 1 on top, 1 on the bottom. That's how we cancel things. 1 on the top, 1 on the bottom. We've got dv equals m. Then we divide both sides by v. Cancels here, and I get d equals m over v. or B. Hopefully that's what you got. Here are some practice problems for you. There's 8 practice problems on this page. I encourage you to pause the video, get a piece of paper out, write each one of these down, see if you can solve them correctly, then come back. Go ahead and blow this one up. What do we have to do first? We have to do this multiplication first. 6 times 2 is 12. So we've got 4 minus 12 plus 3. A lot of people will end up in their heads grouping it this way where there's a set of parentheses here, but there's not. When we're doing addition, addition, subtraction, we just go left to right. So 4 minus 12, that's going to be minus 8 plus 3. Minus 8 plus 3 is minus 5. Here we've got to do that parentheses first. 4 minus 6 is minus 2 times 2 plus 3. Very tempting for people to put a parentheses there, but there's not. It's not shown. So we've got to do the times first here. Minus 2 times 2 is minus 4 plus 3 is going to be minus 1. 2 cubed minus 4 times 8. 2 cubed is 2 times 2 times 2, which is 8. So I get 8 minus 4 times 8. 4 times 8 is 32, so I've got 8 minus 32, which is going to be a minus 24. Here we've got to do the division first. We're going to take that division. It's got the precedence in our PEMDAS. And so 18 divided by 6 is 3. 3 minus 3 plus 2. Left to right, 3 minus 3 is 0, plus 2 is 2. All right, a little too far there. Here we're going to be solving for some variables. We want to solve for x. The first thing we're going to do is subtract 5 from both sides. And so we get 3x is equal to 9. Then we divide both sides by 3. And we get that x equals 3. The next one, there's a few different ways of doing this. You can multiply out the 2 and the 3.5, and that's just fine. You get 7, and then you solve it that way. But one of the things I notice is there's a 3.5 on the right, and there's a 3.5 on the left. So what I'm actually going to do first is I'm going to divide both sides just by 3.5. You don't have to do it this way, but you end up with something that looks like that. 3.5 over 3.5 is 1 is equal to 2q. And now I can do that with a calculator without having to figure out fractions and things like that, because I took those out in my first step. And so I divide both sides by 2, and I get 1 over 2 is equal to q, 0.5 or 1/2. In chemistry, we use a lot of symbols when we're talking about our variables. So it's not just x and y and z and things like that. We sometimes use these funny ones. Here I've got one that says triangle T. That triangle is the Greek letter delta. It means a change in temperature, and we'll see that in some equations later on in the class. So what am I going to do in this one? Again, I can multiply them out, but I'm going to use the fact that I happen to know off the top of my head that 9 and 18 are divisible. So I get these canceling over here. I get these, and just left with a 2, and I get 2 times 4 is delta T, which is 8. Okay, last one. Here, when I've got problems that are written as fractions, it's sometimes really hard to visualize how they are. And so what I usually do is I'll actually go ahead and write them as fractions so I can see it a little bit better. Because if you can't see it really well, it's sometimes hard to know, do I multiply by y, do I divide by y? But when you see a y, and it's very visibly on the bottom, then you know that in order to cancel it, you need 1 on top. And so I'm going to multiply both sides by y. And so I get 12 over 7y is equal to 24, because these guys cancel. Now, I want to get y by itself, so what I'm going to do is I'm going to multiply by 7 over 12. My 7's cancel, my 12's cancel, and I get y equals 24 times 7 divided by 12. And you're certainly welcome to grab a calculator out and figure that one out. You don't have to do it in your head. But I know that 24 and 12 cancel, I get a 2 here, and I just get 2 times 7, which is 14. I get y is equal to 14 in this case. So practice your algebra. Make sure that you're comfortable doing it, because on our quizzes and tests, there's going to be a lot of algebra. And if it's the algebra is what's taking you a lot of time, then you're not having as much time to focus on the chemistry. So good to practice these things and get used to it. Now here, we're going to solve for variables instead of solving for numbers. We're going to do that both ways in this class. Some days we're going to have equations and we're going to solve for the variable first. Some days we're going to have equations and we're going to solve for numbers first. And I do that on purpose so that you get experience doing both, because sometimes one way works better than the other. So we're going to take a moment, pause the video. I want you to write each one of these down on a piece of paper and try solving them. You're going to solve for a in each one of these equations. All right. This one, pretty straightforward. We're just going to subtract b from both sides. And so we get a plus b minus b is c minus d minus b. These guys cancel. We get a equals c minus d minus b. All right, our next one, we're solving for a. We just need to get rid of that b, so we're going to divide both sides by b. What did I do wrong? Right, I can't just divide c by b. I have to divide the entire side, c plus d, by b. So make sure that when you're doing algebra, dividing, multiplying things, that you're doing it to the entire side, not just one part of the side. My b's cancel here, and I just get a equals c plus d over b. All right. Here, I've just got a bc that I need to get rid of. Do I have to do anything like multiply and divide the c's and the b's? And the answer is no. Right? Because if I had a minus 8, you're like, okay, let me just add 8 to both sides. But if I had a minus 2 times 4, you wouldn't start multiplying by 2's and 4's and dividing, trying to get those out. You'd be like, well, 2 times 4 is 8. And then I just add that to both sides. You can do the same thing when you have these double variables. B and C just represent numbers. So, you know, in your head, put 1 times 1. What can you do with that? That's pretty, a little more straightforward when you think of them as actual numbers. All right, so what are we going to do? We're going to add BC to both sides. And so we get A minus BC plus BC, which cancels, is D plus F plus BC. And so we can just get that. A equals D plus F plus BC. And our last one is the most complicated of the ones we're going to be doing. We've got C times A plus B equals D. When we've got that multiplication on the outside, the first thing we need to do is get rid of that multiplication. Then we can get rid of the subtraction. Don't try to do the subtraction first. You can't just subtract B from both sides, because you actually don't have B anywhere. Because if you multiplied out the left, you have CA and CB. And so you can't just subtract B. So what I'm going to do is divide both sides by C, and I get A plus B over, my C's cancel, is D over C. And so let me just write that a little cleaner. Now I want to get rid of my B, and so in my next step I'm just going to subtract out B from both sides. And I get A plus B minus B is D over C minus B. On the left, those guys cancel out, and I get A equals D over C minus B. So there is some algebra that we need to be able to do in order to be successful in this class, because there's a lot of math. Even though we're dealing with the concepts of chemistry, there's a lot of math. So being able to do these algebraic manipulations, being able to put things in our calculator in a very consistent way that we're always getting the right number, at least for the numbers we wrote down, is a good practice to have. Thanks.